Today we're going to talk about blueprint reading. In Canvas, you have a copy of this image file, and you also have a Word document that is going to be a test about this image file. So let's go over what we see. We have a blueprint of two separate pieces of equipment. We have the depth gauge and we have the tool maker's vise. So let's talk about the depth gauge first. What do you think the depth gauge does? Don't overthink it. The first thing that popped in your head is probably true. It measures the depth. So what we're going to do is talk about what you see when you look at a blueprint. You need to look at the whole thing before you start just answering the questions in the test. You need to understand what you're actually looking at. So we have different views of this depth gauge. You have the isometrics and some symbols that you already know. You have the depth symbol, you have the diameter symbol. You've seen those many times before. You have the different parts, all the parts you have in your bill of materials here. So make sure you look at the bill of materials so you know which part is what. You see in the bill of materials that this part is made out of CRS. CRS stands for cold rolled steel. Okay, so CRS is cold rolled steel. Cold rolled steel is the material that all of this is made out of. Now that you understand threads, when you're looking at the thread specifications, you know what these mean. You have a 5/16 24 UNF 2B thread with a depth of 0.375. You know that the 5/16 is the major diameter. You know that 24, those are the threads per inch. You know that the UNF, that is the series. And UNF stands for Unified National Fine type thread. This one has a UNC thread, Unified National Coarse thread. They both have a B on the end. See, these have a B on the end. This thread here has an A on the end. If it has a B, it is an internal thread. If it has an A, it is an external thread. So anything with a B on the end, those threads are inside the part. See, they're inside the part. This thread is on the outside of the part, so it is an external thread. So you need to see how the part is created. It also tells you that it has a pitch of a 0.8 raised knurl. What a knurl is, this is a knurl. See the little metal grip? That is a knurl. So that is what a knurl is, and they're telling you how they created that knurl. So you have a knurling here, you have knurling here, because those are the grips that you would turn to fit into the part. So you have an orthographic assembly drawing, an isometric assembly, you have the actual detail drawing. These are the details of each part that make up the entire depth gauge. You have an exploded isometric, and then you have the machining operations. So you need to read through this because this tells you how they're going to make each part. It tells you important things like what the handle is made from. It's made with a lathe. So a lathe is a milling machine that will create these parts. Typically, if you've never seen a lathe before, you put the material in it and it spins really fast, and then you can cut pieces away. Think of a table leg. That's how they make the shape and the design on a table leg. I may ask you, well, what size drill is used to make the base? So it's a number 7 tap. That is a number 7 tap drill to make that 0.375 deep cut into the base of the part. So the pitch of the knurling, it tells you the pitch of the knurling and how it was made. So you need to look at all of these things. We also have our tolerances. Okay, this is the tolerances, the limits. So your machinist has to create this within this amount of precision so it will actually work. So when I ask you what the tolerance is for something, well, if it's a measurement in millimeters, the tolerance is plus or minus 0.5. If it is a decimal with only 2 decimal places, then your tolerance is plus or minus 0.01. Decimal inch 3 places, plus or minus 0.005. If it's an angle, plus or minus 0.05 degrees. Okay, so these are the tolerances listed on the blueprint of these parts. Now, let's move to the toolmaker's vise. Okay, this is the toolmaker's vise. You have the parts, you have the handle, you have the shaft, you have a drive pin, you have the base, and you have the jaw. Inside the jaw, it has a hole that you can't see because this piece is in the way when you place the shaft into it. So we call this a blind hole. This is called a blind hole. Now, when you put the shaft into that, this drive pin goes in this tiny hole here, and it's going to actually stick into this notch, so that keeps it from moving in and out. So once you put the shaft in, the drive pin will lock that into place. See the detail here for the drive pin? And that is my cat. So welcome to the world of teaching there, Sheldon. So here's the drive pin. Notice that the depth of the drive pin piece is only 0.44. So this 0.44 piece here is what's going to go inside this blind hole, and then the drive pin is going to hold it in place. You have some measurements that you normally don't see on our prints. We have the SR 0.095. That is a spherical radius. The spherical radius. So look for that. This has knurling again. This has knurling again. All dimensions are in inches unless specified elsewhere. So when you call this up on your computer screen, take the time, look at it carefully, zoom in, make sure you understand if I ask for the width, looking at the parts, well, this is the front, this is the top, and this is the right, so the width is going to be on the front view. So think about everything that you see and look at it carefully. If I ask for the series of a thread, you know what that is. If I ask for the pitch, you know how to understand. Okay, the pitch is 1 over the threads per inch. So look at your blueprint carefully and then go to your Word document in Canvas, answer the questions, make sure you type your name on your Word document, and then submit it to the account. Thanks, guys.